There we go. It's not marked as attendance yet. Oh, well. Oh, now get rid of me. No one wants to see me. Okay. So today you're going to have polynomials. Friday was 1x squared and 2,5. It was 1x squared up here. This is not going to equal 1. So not equal to 1. At least when you first see the question. But you got to be careful. Within this section, there's a ton of GCFs. So always, even if I go against that during the notes today, if I forget, always make sure you get a GCF out first. I just realized too, I'm going to sound terrible. I forgot to put my microphone in. So now we're stuck with the bad microphone of the computer. Sorry, and then you hear this too. Click, click, click. You hear all the hitting on the screen. So my bad, dogs. Riff. Okay, so look at the first one. I have 3x cubed. Well, this should give it away right away. 3x cubed, x squared, x. There's at least a greatest common factor of x. But there's also, and never, ever, ever, ever write this. Never write these out as prime factorizations. This is your brain. This is what your brain does. It says, okay, let me look at 3, 15, and 18. 3's in common. So, good. Jameson, you're up, right? Weren't you first? Didn't I say you got picked on the calculator? Yeah. All right. Have you done anything yet? Yeah, I did that. You did the first one. My bad, dog. Roof again. Enter. Okay, nice. Student number 3, Caleb. Hey, did you swear? Oh, you said shoots. Okay, it's hard with the masks. Okay. All right. All right. So we pull out a 3 and an x, and then we end up with something that's simply MA-able after that from Friday. Got it? So it's not going to be a complicated question like I'm going to show you later. Always look for a GCF. If you got it, take it out. Then look on the inside, and I think for the first time this year, you have to factor again. And it's a simple MA. Now be careful with 6 and 5. I know some of you might be thinking it should have been 2 times 3, right? 2 times -3 is -6, but you need a sum that's 5 in the middle. Don't ever forget about 1 times a number is a possible, M. And then when you A those two numbers together, sure, I get 5 as a middle term. Everyone okay so far? Caleb, are you all right? You seem to get like pretty intense when you got your number called there.
No, I just thought it was like a kid behind me.
Gotcha. All right. Do you have a GCF? Yes or no, Caleb?
Oh yeah.
What is it?
Isn't it 5?
And then you're left with, I'll do this part for you. Times tables, don't make mistakes on that. And now what's left over? Is that factorable, yes or no? Yes.
I think, yeah, it is, because I think.
What multiplies to be 10 and adds to be -7?
-5 and -. No, wait. -5, -6.
So then what does that mean these factors become?
It's going to be x. One of them's going to be x minus 5, and then the other is going to be x minus 2.
Can I switch those?
Like in the order?
Yeah. X minus 2 first and then x minus 5?
Yeah,
Absolutely. You can't switch 5 minus x, though. Yeah, if you're thinking that you're worried about what I can or can't switch. Okay, so that's the point there. This is not your classic, what do I do when it's ax squared? And you're going to see it's going to be something special. All right, so make sure you look for a GCF today in all of your work here. And then just to double check and get somebody else, it takes time. I couldn't care less. I like talking to the students. Right, Emma? Emma, what's the greatest common factor from way back in the cheap seats, right? Way back there. What's the GCF?
6.
6, and then what else? Otherwise, you're going to cause yourself problems. 6x. And then there you go yet again. This is not going to be a tough factoring situation now because it's Friday. All you have to do is MA. 6 times 5 is 30. That's good for Euler's good factors. 6 times 4 is 24. And then x. Yeah, so I'm thinking about the distribution. Good distributors are good factors and vice versa. And then what next? Emma, I gave you a chance to think. Don't forget the 6x. This is the point of that one question up here. Let me go back up to the Bellwork quote, quote, quote. This is you take out a 2, and then this is what you're left with, but they didn't have the 2 or the 2y shown out in front. That's why that is wrong. So a lot of times in this question, sorry, Emma, a lot of times in this question, people are all proud of themselves that they factor the next thing, but that they don't write 6x in their final answer, and they lose it. And that will be wrong. So that was the point of that one up there. Go ahead. Very well said. Sometimes say times the quantity if you want to really impress somebody, but whatever. Your times implied parentheses. So perfect. Okay, but now we're really going to end up having questions like this. Now, I love the book. Write none of this. I'm not going to give you time. But I do like how they show the FOIL, because good FOILers, say it, good factors. It's the reverse of that. So that's what we have to think of. And actually, one of the methods of factoring these complicated ones is just do it. Nike. Just do it. Just undo it. Good FOILers, good factors. Undo the FOIL, and then check your answer, and you're done, and you move on. That's what I used to do when we used to teach a class called Algebra 2 Honors. I don't know if you ever heard of that. The rest of the state of Illinois has that class, by the way. And I would just say, just do it. And then maybe show a trick method on things that are really complicated. But let's look at this FOIL real quick and then just show what the book does. The book is amazing. Understand you're going backwards. That's the point of these arrows. We have to somehow figure out how to go backwards and factor 6x squared plus 11x plus 4. Guess what? The the A number is still the middle term, but the M number is special. And I just want to give the book credit that they do cover what we've covered for years at Lockport, and I hope your last year teacher did if they did show you this. The M number is not C. It is now going to be whatever A is times C. And it's just because how factors work with polynomials and how the FOILing process works. So that's what you're going to have to accept. So now take this, and now 6x squared plus 11x plus 4 is the question. And then go ahead and write this down as formal notes. And then reverse the process. But here's the problem, like I noted. M is not 4. It is 6 times 4. Do you guys remember this from last year, yes or no? Anyone have any recollection of doing this last year whatsoever? Or maybe it depends. Maybe your teacher said no trick. You're just going to unfoil no matter what the polynomial is. And that's possible. I know I used to do that back in the day. I think there is when it's a little bit more complicated. This is good to have as a process. Okay, so all you have to do is know that, and then go through what does multiply to be 24 and adds to be 11, and the answer is 3 and 8. And then notice what I did with 3 and 8. I split up the middle term into 3x and 8x, which still equals 11x. And then what method, when I put those parentheses, what is that called when I put those parentheses next? Starts with a G. GR, come on. Somebody yell it out loud. GRO. GROU. We're running out of letters. If this was Wheel of Fortune, I still couldn't hear it. Someone's like under deathbed. Grouping. Thank you. All right, so after I split up the middle term, 11x, into 3x and 8x, the magic numbers that fit MA, then you group, and then you end up with good FOILers, good factor is the right answer. Because you could check that and FOIL it and see that it is the factored form of that. Anyone remember this? One hand, that's it? Couple kind of recall this? I just want to see if they did do this last year. Again, you may not need this at all. If you are very numerate, if you are very good with numbers, you can visualize and multiply and know your times tables, then just unfoiling is going to work. It really is. And I think the very first one, I am going to do that. Maybe we'll show both methods on this and then make choices after that. Okay, so this one we will do method 1, method 2. I want to do method 1 first because I don't want you to know the answer. I want you to try to figure it out. I want you to go through that struggling process. And when you get called, it's like the deer in headlights thing. Like, oh my gosh, I'm on task right now, and I gotta show my number skills in front of everyone. Aiden, are you ready, Aiden? Aiden?
Yes.
Okay, I didn't hear you. All right. So Aiden, you got 10x squared plus 17x plus 3. We're just going to undo it, man. Why? Let's focus on the 3. You must understand that I am unfoiling. There is only one possibility that could equal 3 for last. What times what equals 3? 1 times 3. And by the way, the middle term's positive, so it would have to be plus 1 plus 3. Good foiler, say it, Aiden. See, this is what you're doing. You're unfoiling, so that must be the case. That's why I don't want to complicate things. I already got half of my answer. Now the problem is, what times what equals 10x squared? I got 2 possibilities. And then they could be in either set of parentheses. But what times what equals 10x squared?
You get 10x and 1x.
It could be 10x and 1x, good.
5x
5x
and 2x.
and 2x. Now is the time where you start going, your computer brain, and then you start thinking, if I put this here, and then I do O and I, how do I get 17x in the middle? Okay, so what do you think this is going to be then? How do I get 17x? Would it be 10x 1x, 5x 2x? What do you think it would be? 2x 5x? Let's see if you get it right. And you don't have to. So I'm going to make you say something. Tell me what to put right here. Hurry up.
5.
Okay, so you're going to put 5x, and you look very frustrated. So he's like, oh, you made me do that. And then what's the other one? Because here's what it is, Aiden. It's just guess and check. And now we check. What's 5x times 3? Are you getting excited? What's 1 times 2x? What's 15x plus 2x? Boom, shaka, finish it off. Laka, you at least know that. So we got lucky. He frustratedly said 5x because he's like, I don't know, you're making me answer right now. The point is, he could put 2x and 5x and check and know he was wrong. What does he use next? It's on the other side of the pencil. It's called a what? An eraser. All right? And then you erase and you try again. 10x and 1x would not have worked any combination. You know, and we should be able to see that. If I put 10x here, that'd be 30x on the first multiply. That's huge. All right? So we know that can't be a possibility. That's what I mean about when you become a good foiler, factoring becomes infinitely easier. That's your answer. All right, fine. Let's do the long way if people want something comfortable. All right, and let's get another student if they remember what the long way was. Long way. And sometimes when I show 2 methods, absent. Sometimes when I show, hey! Sorry. Sometimes when I use 2 methods, it's you again, people get confused. Please know that we're going to have the same final answer at the end. But method 2, the trick, what is M, Aiden? If you remember what we did back up there. It's not 3. What is M? Oh, you take this times this to get M. 30. Now this is going to be crazy. Oh, and I forgot to write this up there. I'll show you what crazy, I don't want to say crazy students, but students that don't good foilers, say it again. Good factors, they're horrible. They don't think of FOIL. They never think of FOIL. I'll show you what they do wrong. By the way, what's A, Aiden, in this crazy method? A is the same as yesterday.
A is the same as yesterday?
Friday. A is always A. What did A, when you're doing your method for factoring Friday, what term was A? I'm confusing you. It's just 17. The middle term is still A. Okay, remember that from the other factoring? Now, hey, you got to cover that nose, by the way. We're in COVID. All right? Yeah, the person behind you. Okay, what 2 numbers multiply to 15? Multiply to 30. By the way, something just slipped out there. Anyone hear that number I just said? I was thinking of the answer. What multiplies to 30, but then the same 2 numbers add to 17?
15 and 2.
Okay, so it's 15 and 2. This is the ridiculousness I'm going to get from people. Oh, magic numbers are this? Good, I'm done. X plus 15 times X plus 2. And I want to take my computer and smash it up against the wall. Yes, I get violent. I mean, in my mind I think about it, but I won't do it. Maybe in my final year, when I'm done teaching, I'll smash this computer. What's X times X? What's x times x? Is it 10x squared? Yes or no? Could this possibly be the answer factored form from the question that we have up there? Boy, I will get goofballs that write that as an answer. They're not good foilers because they don't understand why I have you say that every day. You write an answer that makes absolutely no sense because you're a robot trying to find a method that I used, but you stop short and don't even think about your answer. So really what you're supposed to do is use those magic numbers and split up the middle term. So Aiden, I'm not going to be mad at you if you always use this, and I don't know what's faster. I think in smaller, numbers that we're dealing with, we should always try the first method. This method will always work though, as long as you get the right magic numbers. Next, Aiden, what is the GCF of these first two terms? 5x, and I'll do the math after that. I hope you're capable of knowing that that's 2x plus 3. Good foilers, good factors. I double check. 10x squared, 15x, didn't make a mistake. And what should you take out of this 2x plus 3? If you remember the hints I've been giving you. 1. You want to see that 1 so you don't lose a number there. And then lo and behold, you end up with the same answer that you had doing it the other way. 2x plus 3 is a binomial GCF. And then 5x plus 1. This is why you want to write the 1 so you don't lose that. That's why I want to pull out a 1 and see it. Notice it's the same answer done a different way. This way always works. So if you want to commit to it, that's fine. I just think we should avoid it. We should try to think of unfoiling. Like on this one. Guess what? Because 2x squared is what you see there. So who's up? Nice. Dude number 1, Ashley. Did I write the names? Okay, no, I didn't. Here's why, Ashley. We're just going to do method 1 on this. Because one of the two factors is real easy. What equals 2x squared? What has to go here and here? I don't care what order you use. And again, good foilers, good factors takes care of this. This is when I would always use method 1. When there's only one possibility in F or L. Our last question, L, there was only one possibility. And now we can just play with it until we get the right combination. You already know it? Sometimes people are really quick with this. And by the way, I'll let you think of it as I keep blabbering. Is there a GCF? I forgot to look. Is there a GCF? No way. There's a 1x in the middle. Last term doesn't have an x, so there's no GCF. You know the combination now? You must tell me something now. So give me something that multiplies to be negative 21 and then put those numbers there and there. What equals negative 21? When you multiply, what multiplies to be negative 21? Just need your times table. Just give me something. Okay, so you're going to put negative 7 and 3, and I'm going to go in the order that you did. And let's see if you get lucky. What's 2x times 3, Ashley? 6x, and then negative 7 times 1. What's 6 plus negative 7? Negative 1x. Is that what we have? What's the only thing I need to do? Say that again. Switch the order or switch the signs. Sign everywhere. Sign. You guys probably don't know that song. Do this, don't do that. Can't you read the sign? Anyone know that song? Oh, you kids these days. All right. Now, don't you get a positive 1x in the middle? Yes or no? This is a trial and error method. All right. And the more numerate you are, the more you try to practice those times tables, the faster this is going to work. I'll maybe force myself on the next one to do the long method just so you get used to it. No, that's a lie. We'll do it on this one, though. But this one, no way whatsoever. So here's my next student. This one is super small numerically. Student number 17, Nathan. We are doing method 1 for sure, which is just unfoil. Method 1. What absolutely has to be in here and here for 2x squared?
Wouldn't have to be 2x and x.
Yep, and it could be x and 2x. It doesn't matter the order that you put those in, as long as this equals 2x squared when you're done. Now, for minus 6, that's what goes here, but then you have to start thinking about the middle term as well. Don't feel bad if you get it wrong. Just check. Tell me, what are you going to put?
-3 and 2.
And is he right? Well, let's check. What's 2x times 2?
4x.
And then what's -3 times x?
-3x.
Does that add up to -1x, yes or no?
No.
What do you have to do?
Reverse the signs.
Reverse the signs. And there's your guessing and checking. There's the use of the eraser. And now that I know, when I flip those signs, I flip it to a positive 1x for a middle term. Good FOILers, anyone? Good factors. And I swear to dog, you can do the same thing with this one. Because -1, there's only one product. But we'll go ahead and do method 2 just for practice. All right, so method 2. We're going to make it, even if you are a super great and supernumerate and you can figure out the answer, we're going to make you do method 2. Why won't that finish? There we go. Let's pick on a student. Pick on? No way. We got to make them feel alive by answering questions. Braden, nice. Braden, did you go yesterday or Friday? You did? Okay, I thought maybe. I like getting somebody new. Who has not gone yet? Calculator hasn't picked you yet. Come on, raise your hand. Okay, it's not a trick. All right, I won't make you go. You haven't gone either? Right back there. Just interesting to see if the calculator skips certain people. Braden, what's M in method 2? You are correct. It's the product of 10 and -1. I'll write that officially since this is kind of newer. And then what's A? All right, and then what are the numbers that multiply to -10 but add to +3? So it's 5 and -2. I like kind of writing it over here. And then Braden, just because it's new, this is what you do with it. Braden, I'm going to write this like this too. You split up the middle term into those magic numbers as coefficients. I'm going to write -2x second, but then this is what you need to do with it. You need to make this a big fat plus negative here before you group. That plus sign should be in between those two parentheses. What's the GCF of the first one, Braden? This is what I mean about this always working if you are, if you get the right numbers for the MA numbers. And then what do you pull out of the second one? What kind of one? What kind of one? I couldn't quite hear you. -1. That's what I thought I heard. Because remember, for grouping, these have to be exactly the same. So I have to pull out a negative in order to make that grouping work. Right? And that's why I made it plus a negative, so I saw both those terms as negatives with the plus sign in between. And then final answer is you pull out that 2x plus 1, and then you're left with 5x minus 1. If I would have done, whoops, I lost an x there. If I would have done simple MA, I would have started with 1 and -1 as the last two terms, because that's the only thing that could equal -1 for last. And then going through a process of what is it in the front. 2x and 5x, where do they go? Could it be 10x and 1x? You know, that's the guess and checking. Okay, then here's what I mean. 2 more. What time is it? 9:60. We're doing it. Hey, student number 1. Nice. Ashley, you get to go twice today. Here's where, and I did this last hour, because first hour, my mind's a little cloudy, you know, I'm just like, probably wasn't all the way into it. So I got lucky. I started doing MA, man. I started multiplying 29 or 21 and -14. And I kept going, and I'm like, whoa, these numbers are huge. And I caused my own demise. Because Ashley, is there a GCF, yes or no?
Yes.
What do they have in common?
7.
That reduces this polynomial quite a bit to very manageable. And I would argue that half the class would go right to method 1 now and unfoil. Because -2 is the last term, there's only a couple possibilities. And same thing with 3x squared. Which method do you want to do, Ashley? It's up to you. Method 1 or 2? You just want to unfoil it, or do you just want to go through a comfortable process that will always work? You want to do 1. So if you're doing 1, then you're doing this only. You're guessing and checking. And I'll wait for your answer. Just give me an answer. What do you think it is? Looks like you already have it, no? Okay, so what would this have to be 3x squared? 3x and 1x. I agree. Now it's about, okay, how do I get -2 in the right combination to get the middle term? Just write something down and then we'll check. Or tell me what to write down and we'll check it. So you say -2 and 1. So -2 plus 1. Check the middle term. This is 3x. This is -2x. Is that good or bad? So this is 3x. This is -2x. Does that add to be -5x? Yes or no? No. We just need to make a change. Might need a couple changes. Try something else. There we go. Awesome. You know we need a bigger like middle term quicker. We got to get a -5 as that leftover. So this is -6x, and now it's +1x. So I do get the -5x. And I still have -2 as a product. I still have 3x squared as a product for L and F. So method 1, I think, worked out pretty well there. Last but not least, what time do we get out of here? What does it say on that schedule there? Huh? 30? Okay, I got plenty of time to stamp then. We are a little bit faster than the other one. Let's do the second method no matter what on this one, just for purposes. That's baloney. That's way too small. No, I refuse. We're in honors. We should be able to unfoil this. Natalia, what absolutely, positively has to happen in this first set of parentheses, like here and here, meaning what equals 3x squared? It's only one possibility.
3x.
So that's where we start. And this is where I implore you, method 1's the best if one of them has no other option. Okay, now it's a guess and check game. Remember, this must equal -2y squared, though, no matter what. So what do you want to put there? Don't be afraid. Don't be afraid to be wrong. Just put something. So go ahead and tell me. What do you want?
2 and 1.
So you want to put -2y, right? It's got to be 2y, and then +1y, because it still has to equal this as a product, right? Now we check the middle term. What's 3x times 1y?
3x.
And then what's -2y times x? And then all we have to know is what's 3 plus -2? 1. Boom shakalaka. We're done. All right. Since it's checks, that is the factorization. Because good foilers, say it. Good factors. Stop sharing.